So for this video, we're going to be looking at what happens when the exponents of x and y are between 0 and 2, which means that they are not going to be whole numbers, so they're going to be decimals. And we're also going to be looking at what happens when b is also changed. So just to get an idea, we're going to start with b just equaling 1. And we're going to see what happens to our shape and our graph when we change it. So right now I have the steps at 0.5 just to try to get an idea of what's happening and to maybe make some predictions. So I'm going to move this to 1.5, and I see that there is this just arc that is made between 1 and 1. So when 0, so at 0, 1, and 1, 0 is where this arc is connected. So now let's see what happens at 1. So obviously we just have this line, and again, it's between 1, it's 1, 0, and 0, 1. And then again, I have this arc, but unlike the other one, it almost seems to be inverted and just facing downward rather than facing upward as the last one was. And then of course at 0, we're not going to have anything. So now I'm going to change my steps to a smaller number. We're going to go 0.25 just to try to see some other things. So I'm actually going to start at 0 this time and just work my way up. So at 0.25, I see that I have a similar graph to what we did at 0.5, but it's a bit more curved inwards towards the origin. So we're going to see if that happens again. Again, here's 0.5. So there's that downward arc that's, again, moving towards the origin. So at 0.75, I'm merging towards a straight line, but I'm not quite there yet because I do have some curvature, and it still does seem that I pass through the points of 1, here it's 0, 1, and then the other point would be 1, 0. So now I'm going to move on to 1. We know that's a straight line. And then for 1.25, I see that my my curve has now gone upward. So rather than merging towards the origin, we're now merging away from the origin. And this continues to happen throughout until I'm back at my circle. So what it really looks like is happening is that these I'm going to continue to call them arcs, are just approaching this, I guess, quarter of the circle that we're trying to create. So you see that here that we go from just having a quarter of the circle to having the entire circle. And then once we move away from the circle, it seems like they are growing close to that line of x plus, 1 minus x equals y. And then from there, it shifts downward to where it's merging towards 0, 0. So now we're going to change the steps again, just to kind of see if there's anything that we're missing, see if there's any patterns that we're not seeing. So we're going to work backwards from the circle this time and moving to 1.9. Again, here we have that quarter of the circle, this arc that's merging away from the origin. And if you look, it really does seem to be very close to this aspect of the circle, this upper corner here. So now I'm shown this new kind of curve that I have going. So instead of just ending the arc at this 1, 0 and 0, 1 points, it seems that it continues. And notice that this happens when the decimal here is even. So we're going to see if this continues for the other even numbers, but I just wanted you to make note that 1.8 has this 8 is even, so maybe that could be significant. So just to continue that, again, we get back to our arc, and notice that 1.7, that 0.7 is an odd number, because 7 obviously is an odd number, and we no longer have those extensions. Oh, now we see that we have something that resembles this circle, but instead it's more sharp isn't the right word, but it's definitely different from a perfect circle. My prediction would be that the term 16 has something to do with it. So I know that 1.6 and 16 are entirely different numbers, but they may have similar properties in that um, they are perfect squares. I am not sure about this. That was just my immediate thought when seeing this. So now back to 1.5. I'm noticing that with the odd decimals, so again, when I say odd decimals, I'm just talking about the decimal place. So whatever this tenths place is an odd number. I'm noticing that when that happens, there is this arc going on. And we're slowly getting from that like circle, the quarter of the circle, and we're slowly coming closer and closer to that line of y equals 1 minus x. So now at 1.4, I'm back with these tails going on. Now 8 and 4 are related in a sense that 8 divided by 4 is 2, so 4 will go into 8. So that might have some reasoning behind what's going on in this graph, but let's just keep exploring and seeing what goes on. So again, I'm seeing more and more that my prediction about the odd decimals are coming true, that they're just merging closer and closer, because we also saw that when we were looking at 0.5 and 0.25, because while 0.2 would have been a even decimal, 0.25, the hundredths place, I guess that last decimal that we're looking at is what makes it, is what defines whether or not it's even or odd in my definition anyways. So 0.25 would have been considered quote unquote odd, and so that arc was still created. So now I'm back at 1.2. So 1.2 and 1.6 seem to be making what's very similar to the absolute value rhombus that happens when the bases of x and y are absolute values, which you'll see in a later video. But it seems that they're really approaching that. So that could have something to do with 1.2 or 1.6, but we're not sure, so we're just going to keep going. So again, 1.1 is almost at that straight line, but just not quite. And then finally we see our straight line. And then from here, we're merging towards our origin now. And again, 0.9 is an odd decimal, so that is consistent with our prediction. Now this is interesting though. We see that it kind of goes inward on all the arcs rather than going outward as it had for 1.2 and 1.6. It's also interesting because 0.8 or 1.8 rather had the tails going on. So I wonder if when it's less than 1 that it kind of inverts itself. So what the patterns that we saw for the shapes that we've already observed maybe flip to so like when 1.4 and 1.8 showed that the tails, maybe 0.6 and 0.2 will now have those tails, but let's find out. Again, we're coming to the origin now. So as predicted, they do have the tail, or 0.6 at least has the tail. But what's interesting is this curve right here is no longer facing away from the origin, but it's actually facing towards the origin. So that is probably also a pattern that we can note. And again, for the odd decimals, they are just continually growing towards the origin. So, and here at 0.4, we see that it's almost like a more condensed version of 0.8, and in that these are steeper. So this shows that our prediction is holding thus far that 1.8 and 1.4 had similar shapes or productions. And so now 0.4 and 0.8 are having those similarities as well. But instead of having tails like they did when they were greater than 1, they're now almost constructing a star-like shape, which is again the inverted version of what 1.6 and 1.2 look like. So there again is our odd decimal. And now 0.2, however, has this inverted arc to where it's towards the origin. But if we zoom in really close, we see that it does kind of resemble 0.6. I'll move back to 0.6. That's 0.5. 0.6, where there are tails, but the difference between 0.2 and 0.6 is that the tails kind of extend. It almost seems like it would be on the x-axis, but it's actually not. It's actually not touching the x-axis. So it kind of seems like there might be an asymptote going on here at 0.2. And then 0.1 is not even on our graph unless we zoom in. But even zooming in, yeah, we have to zoom in very, very close to see where 0.1 is. And then 0 is, again, the origin. So excuse me, 0 is not existent on this because in no way is 1 plus 1 0. So what we've seen is that 0.4 and 0.8 are similar. 1.8 and 1.4 are similar. And then we assumed that 1.6 and 1.2 were related, and thus we could assume that 0.6 and 0.2 were related, but what we really saw is that 0.6 is actually the only one that had that quote-unquote inverted relationship. And again, that inverted relationship I was referring to is, so here we see 0.6, and this it's going towards the origin and having those tails. Whereas when we look at 1.8 or 1.4, it's going away from the origin and has those tails. So basically what we've seen is that from 1 to 2, there are patterns. And then from 0 to 1, there are patterns, which is very, very interesting. So now I just want to set up thinking about this even and odd difference of decimals as well. I want to see what happens when B is changed. So I predicted that it would just change in size and grow for the evens especially. Not really I hope that the same thing happens with the odds, but I'm not 100% sure, especially since the arc. So they might just curve more into the origin or away from the origin depending on the decimal's location in reference to 1. So if it's greater than 1, it's going to go away from the origin at a faster rate, or if it's less than 1, it's going to go towards the origin at a faster rate. So let's see if that happens. So here's 0.9. So since it's less than 1, we're going to see it go towards the origin. But instead, it actually just moves, which is very, very interesting. And then let's see if the same happens when it's greater than 1. So here's 1.1, and we see that it too moves. And it tends to stay in this upper right quadrant here. So then for 1.2, we get this shape, and I would assume that it just grows as well. So what we've seen is that between 0 and 1, if it's an even exponent or even decimal, then we know that changing B is only going to make the shape bigger. Whereas if it is odd, that it's only going to move the function.